Okay, in 8.1, number 2 slides, we're still talking about polar coordinates, but we're going to get into rectangular coordinates versus polar coordinates, um, and converting from polar coordinates to rectangular, and vice versa. So let's get a move on. Converting between polar coordinates r comma theta and rectangular coordinates x comma y. Remember that those are the ordered pairs for polar or rectangular coordinates. Pythagorean theorem would tell us what about r. All right, so here's r, but the Pythagorean theorem would tell us that x squared plus y squared would equal r squared. All right, keep in mind the x and y, that's rectangular, but the r will help us get back to polar or get to polar. And then theta can be found with what trig ratios? Now I want you to think about this, SOHCAHTOA. So let's use SOHCAHTOA. I'm actually going to write that down for you. SOHCAHTOA. We can use tangent if we have x and y. So if we have x and y, think about it from theta. So if I use theta here, and I know x and y have opposite and adjacent. Opposite is my y, adjacent is my x. So if I use opposite and adjacent, again, that's my tangent. And so I can use tangent to relate x and y and theta. So right here, I have tangent theta equals y over x. And then also, if I were to solve the Pythagorean theorem for r, I'd have r equals, a little messed up, r equals the square root of x squared plus y squared. So using both of those, we can convert from rectangular to polar. Okay, so it says, let's convert negative 2 comma 2 to a polar coordinate with r being greater than 0 and theta being between 0 and 2 pi. Now I want you to keep this in mind. If we're going to convert negative 2 comma 2, think about what quadrant that would be in. Left 2, up 2, that is in the second quadrant. So left 2, up 2 puts us in the second quadrant. All right, that will help us with our r and theta. Well, if we're going to find r, we will use the x and y that we know. So let's first find r. R is going to equal, as we found out on the previous page, the square root of x squared plus y squared. Well, what do we know? X is negative 2. We'll square that. And y is also 2. We'll square that. That equals 4 and 4 equals the square root of 8. And if we simplify that or rationalize that, I should say simplify the radical, would be 2 root 2. So there is my r. So far, so good. And now to find theta, you will use the tangent. You will use the tangent of, just start over there. You will use the tangent theta equals y over x. If that's the case, tangent of theta equals my y, which was 2, over x, which is negative 2. Then I have the tangent of theta equals negative 1. Well, the question is, at what angle is the tangent negative 1? So we took the inverse tangent of negative 1. We know it has to be in the second quadrant. The question is, at what angle is that? Well, from chapter 5 and chapter 6, mostly chapter 5, we talked about radians. You would know that theta would equal 3 pi over 4. All right, so 3 pi over 4 would be 1, 2, 3 pi over 4 put us in that second quadrant. I knew it had to be in the second quadrant. That's where the tangent is actually negative 1. It's only negative 1 in the second and fourth quadrant, but I had to be in the second quadrant, so it's 3 pi over 4. So what's my ordered pair? I have my r and I have my theta. I can now write it as an ordered pair to be 2 root 2, comma, 3 pi over 4. Final answer. Okay, let's move on. Here's another example. I'll let you practice it on your own first. Why don't you do it on paper? First, why don't you try to think about that this one is 3 comma negative root 3. That will put you into the fourth quadrant. So I have that marked there. Put you into the fourth quadrant. Go ahead and do it on your own. Hit pause. And then I will make sure I have the correct answer for you, and you can check. Okay, so here's the correct answer of r and theta. Take a look at how I found r. I took my x and my y and I squared it. So you can see here, I took my x and my y. My x was 3. I squared it to get 9. My y is negative root 3. Square that, I get 3. Add those up gives you 12. Take the square root of 12 and rationalize, or simplify the radical, I should say, will give you square root of 4, square root of 3, which gives you 2 root 3, as you can see right there. There's my r. Then using tangent theta equals y over x, negative root 3 over 3. Where is the angle negative root 3 over 3 in quadrant 4? Well, you guys all know that will go down negative pi over 6. So theta is negative pi over 6. But you have to keep in mind, it asks for the angle theta to be between 0 and 2 pi. So I cannot use negative pi over 6. I actually have to go the counterclockwise direction. And that same angle at negative pi over 6 is 11 pi over 6 between 0 and 2 pi. So my final ordered pair is 2 root 3, comma 11 pi over 6. Okay, now let's go the other direction, converting between polar coordinates, r comma theta, and rectangular coordinates. So we'll change polar into rectangular. So let's talk about what we know first, about what x over r is and what y over r is. This will be our cosine of theta. So cosine of theta, remember, is your x equals x over r. And your sine of theta equals y over r, as you remember those from the past chapters. Again, you can see how we'll be able to relate theta to x and r, and theta to y and r, and vice versa. We'll mix those or mess those around just a little bit. All right, so given that we have r and theta down here, if I solve the first one for x by multiplying both sides by r, I would get r cosine theta. And if I solve this one for y, I'd multiply both sides by r, and I'd have y equals r sine theta. So both of these are very important to change from polar to rectangular, knowing that x equals r cosine theta and that y equals r sine theta. Let's go ahead and take a look at an example. It says find the rectangular coordinates for the point. Find the rectangular coordinate for the point with polar coordinates negative 3, comma 5 pi over 3. Again, I'm going to go ahead and look at what quadrant that is in. All right, it's already given to me in polar coordinates. All right, so if you take a look, all right, I go 5 pi over 3. Think about where 5 pi over 3 is. 5 pi over 3 is the same thing as 10 pi over 6, which brings us all the way over here. 10 pi over 6 is there. But it's a negative 3, so instead of putting the point out a radius of 3 here, I go the opposite direction, the opposite way, 1, 2, 3. That point puts us in the second quadrant. So we are in the second quadrant. Okay, so let's go ahead and find a value for x. Remember, when we want rectangular coordinates, we want an x and we want a y. Well, how do you find x? X is found by taking r times the sine, or r times the cosine of theta. So remember, we just learned that before, that we said that x equals r cosine theta. So if we use that, r is negative 3 times the cosine of theta. Right here, remember, this is r, this is theta. Negative 3 cosine of 5 pi over 3. Well, if we just go ahead and solve that, we still have negative 3. The cosine of 5 pi over 3, keep in mind, here's 5 pi over 3 is down here. That's our x value, is actually 1/2. It'd be a positive 1/2. We know that from our learning of the unit circle. And then negative 3 times 1/2 gives us negative 3 over 2. So there is my x value. To find my y value, same process. Y equals r now sine theta. So r is negative 3 sine of theta. It's up here, by the way. R sine theta. Sine is sine of 5 pi over 3. And again, we still have negative 3. The sine of 5 pi over 3 is actually a negative root 3 over 2. Again, this ordered pair here, as you learned from the unit circle, that ordered pair would actually be 1/2 common negative root 3 over 2. So that's where I'm getting those values from. The sine of 5 pi over 3 is the y coordinate. So it's negative root 3 over 2. And if I multiply those, I get 3 root 3 over 2. Negative times negative is a positive. So my final answer in rectangular form is negative 3 over 2 for my x value. And here's my y value, was 3 root 3 over 2. Here's another example. I want you to look at the last example and that you did in your notes and try to do this one on your own, and then I will come back and show you what I did. Hit pause now and do the problem. Okay, so here's what I got for that example. Noticing that x, again, I found x first. Equals r cosine of theta. All right. And then I kept my r value. X equals r cosine theta. Kept my r value. Figured out that the cosine of negative 3 pi over 4 is negative root 2 over 2. All right, so I did plot the point and figure out where it was. And then negative root 2 over 2 times negative root 2. Negative root 2 times negative root 2 is positive 2. Divided by 2 gives me 1. Then for the y value, I have r sine theta. So r is negative root 2 times the sine of theta, which was negative 3 pi over 4. And I went through the same process. What is the sine of negative 3 pi over 4? The sine of negative 3 pi over 4 the sine of negative 3 pi over 4 is negative root 2 over 2. You can see I did go ahead and I went ahead and put the ordered pair right here. All right, when it ends up in the third quadrant, negative, negative. And so that is negative root 2 over 2, and you multiply it by negative root 2, and again, you would get 1. So my ordered pair was 1, 1. So here's some guidelines for a format of final answers for polar coordinates or polar equations. You want to use positive r comma theta, and theta will be determined by r. All right, so just keep that in mind. Theta will always be determined by r. No fractions if possible. R equals 1 over the cosine theta becomes r equals a secant theta. So don't use any fractions. For rectangular, get to standard form if possible. So x squared plus y squared equals 1. That's a standard form. X squared plus y squared equals 0 if you were to see that. Make equations for circles, parabolas, lines. More is coming on that one in the future. And then no square roots. Okay, so this is the second video of 8.1. There's one more video. Make sure you do watch it and go back if you have any questions, or ask me or Miss Zara if you have any further questions.